Okay, AP Physics UT Quest momentum and collisions problem. This is the famous Gale dives on a sled problem. And in a nutshell, you got this girl, she dives on a sled, goes down a hill, halfway down the sled, her little brother jumps on, and then they merrily go down both to the bottom here. And ultimately speaking, what we want to do is we want to find the velocity of the two kids when they get to the bottom of the hill. Okay, now we have many different events going on here. As a matter of fact, I've labeled them 1 through 5 events. And you make a mistake in any one of these events and you won't get the problem correct. All right, let's look at this first event. This first event, the sled is sitting still, and Gale is going to jump on it, and then they're going to move away together. All right, so this first two events, we're going to use conservation of momentum. All right, so we have Gale and her velocity. Here, the sled is at rest. So when she jumps on it, we have a perfectly inelastic collision, and that allows us then to solve for this velocity. Okay, now she's got some velocity, therefore some kinetic energy at the precipice of this hill. So here at point 2, after we find the velocity of the perfectly inelastic collision, we need to find total energy. Well, it's going to be a combination of her kinetic energy plus her potential energy. Now, she's at the top of the hill. I'm using the very bottom of the hill as 0 potential energy. So in that reference frame, I have this H total, which is comprised of these two heights given in the problem. I think the problem gives the total height and then this first drop. But anyways, you can figure that out. Okay, so here's my total energy, and she starts moving down the hill. Now she's going to conserve this total energy. So she gets to point 3, about halfway down the hill. And what has happened is this potential energy has dropped. That means her kinetic energy has gained. So what we're going to do from that conservation of energy is we need our velocity right here at the midpoint of the hill. Now at the midpoint of the hill, the brother jumps on, so we're going to gain mass, lose velocity due to conservation of momentum. All right, so here's Gale bombing. She's bombing down about halfway down the hill. We know her velocity. Little bro's just standing there, no momentum, no velocity. And then little bro jumps on. So now we have Gale, the sled, little bro, and then they move off at some final velocity. And that's what we need. Okay, now after this inelastic collision with the little brother jumping off halfway down the hill, I need to recompute my total energy right here. And I can do that. All right, here the energy at point 4, which is halfway down the hill, I'm going to have a combination of kinetic energy plus potential energy. Now this energy in point 4 is going to be conserved then at point 5. All right, so what's going to happen at point 5? Well, I have this total energy at point 4, which is this term right here, and that has to be equal. What's happened to the potential energy? It's gone to 0. So all that energy has gone into this kinetic energy. I can then solve for this final velocity, and we're done with that problem.